So there's only 2 items on our agenda, really. We're going to do a very interesting activity that I hope you like. I call it a hybrid activity because we are going to do, we'll see how that goes. It's something kind of newish that I haven't tried. We're going to do the Jamboard, like kind of, I'm going to say normal, but you're going to be doing the Jamboard a bit differently this time, where you're going to play detective. That's why I asked you to bring your detective gear. Um, so that is the first part. And then the second part is Desmos activity called the Eye of London. So even though we can't travel, we're going to go and visit some big Ferris wheels. One of them is this Eye of London, which is a beautiful, gigantic Ferris wheel. And we're going to model something with it, obviously related to sinusoidal functions. Okay, so first part, we're going to right away get into our group. Here it goes. This activity is called What If I Told You? And so it's all about sign and transformations of sign. We played with this a bit in the last Desmos, last class. So this one is designed to be like a bit of a detective thing. So let's hope it works. And here it goes. Oh no, this is day 19. I'm going back. Okay, here it goes. And here it comes. So this is called What If I Told You? So I'm going to show you a graph, and you and your, this is case 1. Okay, case 1 from on your Jamboards. I'm going to show you a graph. And right now, I want you to kind of speculate what the graph, what the equation of this function might be. And you can put a little note in your Jamboard. So what if I told you you have a graph like this? What would you think that represents? So you don't need to write it, both of you. If one person writes it and the other agrees, we're good. Now, I'm going to give you a bit more information about this. What if I told you this point where the graph touches the axis, the symmetrical axis, and the y-axis is at 0,75. How would that change the equation that you had? What would that do? So I'll give you a little bit of a moment or two to kind of think and collaborate and think or talk to each other. What is the implication of that point? 0,75, which is this point here, right? This one. Okay. Now, what if I told you that this measurement is 135? How would that change your equation? Now, what if I told you one more bit of information? What if I told you this? And just if it's not clear, that I'm going to maybe give it away, but it's one cycle. So with these 3 bits of information, I need you to show me what your equation may look like. I'm going to go to the Jamboard then, and let's see what we have. Oh my, case 1, okay. So there's a lot of work here. Yeah, okay. There's something about 135 sign of, okay. Let's take a look at our next group. It's a periodic function, is a basic sign function. Not anymore. Maybe the first one was, but after that, things did change. Group 3, the cycle is 60, so pi over 3. And here 60 seconds is equals 1 period, which is 1 cycle. 135 is the amplitude. And some people are speculating that 0,75 might be the cosine. This team 60 is equal to pi over 3, which is correct. Okay, I'm not sure if some of you hadn't really joined the Jamboard, because as I'm going through it now, I can see people now joining and joining. So I don't know if my instructions might not have been clear, but okay. So here we go. Actually, this is only case one. I'm looking at group 5. Suzanne, you can see my screen. Is that correct? You can see the Jamboard. Stephen, Malcolm. Yeah. Okay. Yeah, because this is only the first case. Yeah, all this is one case. Amplitude could equal 135. Okay, and group 6. Okay, here we have an equation. F of x equals 135 sine, and then 2 pi divided over 60 plus 75. That is the first full equation we have, and that is group 6. And group 6 is Andrew and Malcolm. Okay, cool. All right, Andrew and Malcolm, thank you. And then here, group 7, that's okay. Use the period. Okay, so here, that's okay. Sine graph has been shifted. Minimum, maximum period. Okay. So part of this is of course tricky, because we're beginning to understand or to develop how each item affects the function. We have another function here which is identical to the first one, and that is group 8. And group 8 is McKenna, the M&Ms. Awesome. So we have an equation from them as well. Cool. And then here, our group 9, we don't have a group 9, so that's why there's nothing. Okay, cool. We have two equations that are identical, and a lot of recognition what the 135 does. People identify these. So now let's go back to our thing here. And here it goes. So here it went, 0.75. So we'll talk about the implication of each of these things, right? The 0.75 may tell us that the function has been shifted up 75 units, right? So that's one bit of information. The 135 gives us the amplitude, which is another bit of information that affects the function. The period being 60 seconds, that means that it affected the cycle, the 2 pi, and here is our equation. And I think people got it. There's different ways to write it, but this is one way. F of x, which is 135. So now we're making this connection, right? So I want you to pay attention here to make this, to see why this works. So 135 is the amplitude. We can see this link here. The 75 is what the function shifted up, plus the 75. And then the 60, we know a regular period for a basic function is 2 pi. This time, to make it 2 pi, to make it 60 seconds, we divide over 60, 2 pi over 60, and that is our function. Very nice. By the way, this also has a frequency of 1/60th of 0.166 cycles per second. We don't talk about that, the function. And of course, the cool thing about sinusoidal functions is we can write them in a variety of ways. So Suzanne is saying the function might have shifted left. Is that not a possibility? It is a possibility, but in this case, I mean, we can, the 0.75, the 75 is on the y-axis, right? So it's more like it moved up. We could express these as a cosine function as well. And of course, these 2 pi over 60, we could write as pi over 30, right, to simplify that. So this is one possibility, and that's a good point. It's not the only one. So I hope this was a bit helpful, connecting these things, the amplitude and the shift, the vertical shift, and the period. And since that was one, we have actually 2 more of these. So hopefully the first one was a little bit of a warm-up. We're going to go to the next one. So what if I told you Yeah, it looks like could be a sinusoidal function, but let me add you a bit of information. Okay, what if this was 1? How would that change your equation? Or not? What about this point now being 25, 1? And the period being 100 seconds. Okay, so why don't I let you go at it? Just if this may or may not help, but obviously I guess most people identify the reason for the 1. We have a connection with the period. This point really is kind of a consequence of the period being 100, right? We can think of the function reaching a maximum at a quarter of the cycle, back to 0 at half of the cycle, a minimum at 3/4, then back to 0, right? And that, of course, gives us our frequency. So does anybody have a function that they want to share, or should I just go to the Jamboard? You guys are so shy. Okay, I'm going to go to the Jamboard and see where that takes us. Okay. Actually, I'm going to do something. Yeah, I'm going to keep it here. All right. So case 2 now. Let's go backwards this time. We begin with team 8. Still a sine function, amplitude 1. That is correct. Sine of 2 pi over 100. The amplitude is 1, so that didn't change anything. I don't know where to put the 25, 1. Yeah, that's interesting. And I think the 25, 1 is kind of a consequence, right, of the period and the amplitude, of course. And then here, case 2, y equals 1 sine 2 pi over 100 times x, or pi over 50x. Good. Of course, we cannot really write pretty math in this thing, but you guys are doing a good job. By the way, nothing stopped you from using your pen, right? And doing one of these if you want to make it more to make it clear. But this is the only observation I have here for team 6 is that they forgot the x. Otherwise, this is 2 pi over 100. We need the x, and the x has to be inside the bracket, right? Okay, here we go. Sine of 2 pi, same situation here. We forgot the variable, right? I think we're focusing on the transformations. Let's not forget the variable, because otherwise our function kind of perishes. Same thing here. Here, this is a bit different. 2 pi over 100 minus 25. Phase shift is 25. Amplitude and vertical shift is 1. So there's a bit of two ideas here. One is the amplitude and the vertical shift is 1. The amplitude is definitely 1. I'm not sure there was any vertical shift. And again, we're forgetting the variable, so please don't. Okay, case 2. So here's our equation. And this team did 1 sine 2 pi, and then t minus 25 over 100. So they believe the graph is shifted 25. Okay, so that's the second time we see this idea of the graph having a horizontal shift. Okay, and then here, there's some data. We still haven't gotten to an equation here, but that's okay. Identify the period, the amplitude, and let's go to our group 1. So the value is pi over 50. So it's getting the, here I think, excuse me. I think here they got an equation, pi over 50 times x plus 25. Okay, so let's see. Let's go back to this thing and see what is this one? Yep. Okay. So let's talk about the implication of each of these values. Let's think about it. The period is 100, which means this point here would be, well, this point here would be 100, 0. And we know that because the amplitude is 1, this point is at 25. That means that we travel 25 units on the x-axis and 1 unit up, right? And that conversely, I would travel 1 unit down to here and to do the other part. So this point really might be a red herring, or a kind of something that not intended to trick you, but it somehow it did. So all we really needed was the amplitude and the period. This function really didn't shift up or down from a basic. I mean, we can write it as a cosine function, but because it begins at 0, 0, right, and it follows this shape, we can think there was no phase shift. The 25, if we could use the 25, maybe if it was a cosine, but in this case it wasn't. So let's see here, the frequency. I always put the frequency because it's important, talk about it enough. And so here is the function, right? The 1 is invisible as the amplitude, and the 2 pi divided by 100, of course, simplified to pi over 50. And if you wanted to write as a cosine, let's take a look at this one, because some of you, I think, thought about that. If we think of the cosine, then our function would be shifted 25 units to the right, yes? So we would end up here. Oh, sorry, scusi. So either one of these works. The key ideas here are, well, the amplitude, you have the period. This point was tricky. So we're ready for one more. Okay. All right. And we save the best for last. Here it is. Okay. This one is different because it's red. Okay. And then let's see, what if I told you that this was 0, 1? Okay. And what if I told you that the amplitude was 2? And of course, we may need the period, wouldn't we? What if I told you the period was 5 minutes? Okay, I'm going to let you work on it. It does look like from the get-go, is 0, 1, and the shape of the function looks more like a cosine. The amplitude is 2, period is 5. So we are kind of looking at maybe what is the distance to the main axis here. And this main axis really is at -1, if you see that, right? So this could be a bit deceptive. So let's take a look at the Jamboard. Okay. And we'll go back from team 1. Yeah, amplitude is 2 cosine of 5x. Just keep in mind that the when we do the period, and let's say if the period is 5, what we do is 2 pi over 5 for the period, right? We don't, when we write just y or f of x equals sine of x or cosine of x, the period is 2 pi, then we have to divide it to get the value that we want. So this would be 2 pi over 5 for the period. We'll see what team 2 says. I think they're working on it. I'm not 5 divided by the amplitude is 2. There's a function here. I'm going to move it up a bit. 2 cosine of 2 pi over 5 times x. Okay, that is interesting. I wonder if there was a shift up or down, but this is good. Case 3 here. Amplitude 2, period 1 over 150. we actually thinking the units being whatever units are given, and maybe I didn't specify that, meaning minutes, right? So pi over 5 or 150 might be, I'm trying to understand the pi over 150, or maybe 2 pi over 300. Oh, in seconds, got it. Yes, yes, now I get it. Thank you. 2 pi over 300 seconds, which is equivalent to 2 pi over 50. So that is fine. That is very good. Oh, sorry. Man, I suck at drawing. Okay, good. Nice. And then here we have another function. 2 cosine 2 pi x over 5 times x. Again, it may not help, it may not hurt to do these with a 2 pi. I'm going to try to write it better than that. 2 pi divided by 5 x, right? I think that's what this team totally intends to communicate. And 2x, amplitude is 2. Here, 2 pi over 5 x, good. To shift the wave horizontally to cosine, that makes sense. We also can have a cosine, right? Good. Nice. So sorry, I missed the last two teams. I don't want to do that. 2 cosine pi, and I'm making this mistake, 2 cosine pi over 5x. Okay, just so a twist to that one. Minus 1. Oh, interesting. Interesting, because of the size of the amplitude, right? There is a little shift. Good, good, good eye here, Team 7. Whoever did this, I was unable to trick you. And here we know it's a cosine function. So we have a lot of these. So let's go back and see what it is. And we have it. Okay. Oh my goodness, I went back too far. Sorry about this. No, I went forward too far. Okay, so here it is. Yeah, so 2 cosine 2 pi over 5 minus 1. Where does that minus 1 come from? Well, if I start here and the amplitude is 2, I'm going to go from here 4 down here, right? So I'm going to put negative 4 here. That means these has to be shifted 1 down. And these was perhaps the tricky part of this question, that you know, it's kind of hidden because the numbers look so simple. But I think it was Team 7 and maybe another team that were wondering about the shift down. Because otherwise, if you didn't have a shift down, the amplitude wouldn't work. Cool. And of course, let's talk about these just for a moment. If you wanted to model it as a sine function, of course, the period stays, and please notice how this is written. The period is 2 pi over 5, and now we can write this x plus 125, which is a quarter of a cycle, shifting to the left. So it went back, we think the sinusoidal function was shifted, and the minus 1. Cool, thank you. I hope this was helpful. I can see from the first case to the second case to the third case, the answers were more sophisticated. And of course, the cases got trickier with these little numbers. So cool, thanks for playing along. If something doesn't make sense, you can always ask me. I'm recording these, and you can come back and watch the video again as necessary. I'm going to edit all the wait time, as I always do, so you don't have to be waiting, so to speak. Cool. All right. So now we're going to go and do a Desmos. But before we do the Desmos, let me walk you through it for a moment. Let me show you what these Desmos looks like. And it, of course, connects to what we've been doing. So I'm going to show it to you quickly. It's called the Eye of London. I don't know if anybody has been to London, but it's kind of nice little, well, not little, it's a big thing. So this is the Eye of London. It's a gigantic Ferris wheel, and I'll give you some, let me show you what you will see. Um, so there's some facts about the Eye of London that might help you in the next screen. Some of them are interesting, some of them are more useful than others, but you will determine that. And then basically you're going to model, you're going to create an equation that models the movement of a gondola, which is kind of one little card, all the way around this loop. And so that's what you're modeling, the height of a gondola in relation to time, right? So here you're going to think of what assumptions are you making as to what are you thinking? Does you begin here? Does it touch the ground? Do you think the gondola begins here? What are you thinking? Okay, and I can see somebody's already there. Sarah, who is very active very quickly. Not to be mean. Okay, so then here you're going to create your model. Okay, so basically what you're going to do here is you're going to create an equation that models the height of a gondola over 75 minutes, and you're going to model it with one equation here and another equation here. So one may be a sine and the other one may be a cosine that models the same thing. Here is something very important. If you notice, there's no change here in the axis. You have to do all that because you are the smartest people I know in this class. So you're going to come here and you're going to change your settings, right? You're going to change the settings to your axis that work given the information you have. So it's kind of connected to what we just did, but this is critical. If you don't change the settings, your function is going to look funny, and then you're going to go, oh boy, it doesn't look like, it doesn't work. Okay, so be careful with that. And that's basically all. And then here, a little checking in. And there's a couple of questions for you that I'll let you figure out, radians and that sort of thing. And then the other part that I want to highlight is this. Next thing, you're going to pick a new Ferris wheel, and you'll see a bigger picture next. But all I want you to do on this screen is, let's say you pick this one, the Dubai Eye, which at the time was super tall. All I want you to do is put a circle around it, and that tells me what you are going to do. You're going to go and find out how long does that Ferris wheel take to make one rotation, and you have the measurement here. There's better details, and then you're going to model it. Yeah, you're going to model it here. All right, so this is all about modeling with sinusoidal functions. Just remember your axes, you have to adapt them, otherwise it's gonna be difficult. And the assignment, as Sarah figured out already, is already in our course assignments, or here, Desmos Eye of London. And please, if you are not enrolled in day school and you need to get a proof of mark for transfer purposes, there's a very important announcement that I put today. This is a message from our principal. It's a bit lengthy. There's attachments, so do read it in detail. It's there for you if you need that sort of thing. So I'm going to be here. I'm going to let you go to the Eye of London and have fun with it. It's unlocked, and I'll be here for a while till maybe 8:30 or so, 8:40, if there are any questions. Okay, all right, so I'll let you go to it, friends.